Hey guys, today's topic is parallelograms and isosceles trapezoids, Unit 4, Day 2. We were going to identify the properties for parallelograms and specifically isosceles trapezoids. You'll be able to determine the missing angle measure of parallelograms and isosceles trapezoids, as well as determine their areas. So, the first shape we're going to be working with today is a parallelogram. And in the word parallelogram, hopefully you see another word that we've talked about before, right there, parallel. So the definition that we're going to be working with for a parallelogram is a trapezoid with opposite sides that are parallel and congruent. So if we look at our opposite sides, let me indicate those are opposite sides. And these are opposite sides. And what you can see is that our green sides are parallel to each other, and then our purple sides are also parallel to each other. Okay? The properties for parallelograms are that our opposite sides are congruent, and our opposite angles are also congruent. So if we look right here, angle C and angle A are opposite from each other, and they're congruent, which means angle D will be congruent to angle B. Adjacent angles are supplementary, so that means angle D plus angle C is equal to 180 degrees, but also that angle C plus angle B also equals 180 degrees. So any two angles next to each other are going to be 180 degrees. Now, our fourth property is that the diagonals bisect each other. So if we think about a diagonal, which is going to go from B to D here, and another diagonal that goes from A to C here, it says they bisect each other, which means that the segment here from D to the center is the same as from the center to B. It also means that A to the center is the same as from the center to C. And then lastly, any property of trapezoids and quadrilaterals that we've discussed previously apply to parallelograms. So that's like our four angles equaling 360 degrees and things like that we talked about last class period also apply for parallelograms. In order to find the area of a parallelogram, we use the equation area equals base times height, where the letter B represents the base and H represents the height. Now, if you look here, in this picture, the base is this part here, and we know that that would be the same as that base there. Now, the height, though, is important. It's actually not going to be one of your side lengths. Instead, it is your vertical height that creates a 90-degree angle with a base. That is going to represent your height. So our first teacher example asks us to determine the measure of angle R. Now, one of our properties for parallelograms is that opposite angles are congruent. So, since we know that this parallelogram has the measure of angle R and the measure of angle T will equal each other, then the measure of angle R must be 135 degrees because, this angle is congruent to that angle. Take a second and do student example number 1. Think about which property are we looking at? Are we looking at adjacent or opposite angles? Are they congruent or are they supplementary? And how do we determine the measure of angle D? Now, for a second teacher example, it asks us to find the area of the parallelogram below. So here, I know that my base is the 7. My perpendicular height, I can tell by this 90-degree marking here. And this 5 also has a special name. It's called your slant height. And we don't need the slant height for this equation. But later on, we might use slant height for something else. So I just wanted to give you guys a name for that 5. But here, area equals 7 times 4, which is 28. So the area equals 28 units squared. So try your second student example. All right, now we're at isosceles trapezoids. So, real quick review, which of these triangles is an isosceles triangle? Now, if we remember, the word isosceles should tell you that there are 2 congruent sides, which means it should be this one. So if an isosceles triangle has 2 congruent sides, then an isosceles trapezoid would also have 2 congruent sides. So our definition for a isosceles trapezoid is a trapezoid that has congruent legs. That means if we're thinking about this is a base here, this is a base here, because I know those are parallel, then here is one leg, here is another leg, and I know that those legs are congruent. Now, our first property for isosceles trapezoids is the angle created by the base and the leg are congruent. So what that means is angle C here is congruent to angle D here. It is the angle that's created by a base and a leg. It creates angle C and angle D. Additionally, we have another angle that gets created by a base and a leg, which is angle A, congruent to angle B. The second property is that your diagonals are congruent. That means let's find a different color. Our diagonal BD is congruent to our diagonal AC. The length of those diagonals are the same. And then any properties about trapezoids and quadrilaterals also apply here. So some of those include your adjacent angles, if they're along a leg, are supplementary, and that your bases are parallel, and when you add up all the angles, they equal 360 degrees. Things like that also apply to isosceles trapezoids. And in order to find the area of an isosceles trapezoid, you're going to use the area formula for any trapezoid, where you're doing 1/2 base 1 plus base 2 times the height. Again, remembering that your height has to be that vertical height, that perpendicular to the base. So teacher example number 3 asks us to find the measure of angle R, A, and P. Now, one of our properties is that this angle and angle R are congruent, and also that angle P and angle A are congruent. So that means we know right off the bat the measure of angle R equals 115 degrees. Now, we also know one of our theorems about trapezoids is that the angles that are created by a leg, which is right here, are supplementary. So we know that angle P plus 115 equals 180 degrees. So to solve for angle P, we're going to subtract 115. And then the measure of angle P equals 65 degrees. And then we know that angle P and angle A are the same. So the measure of angle A is also 65 degrees. Try student example number 3. And then write a summary. 3 to 5 sentences. Make sure you're using the objective in your sentence and using your correct academic vocabulary. See you guys in class. Bye-bye.